Hello. Now we are going to look at sketching graphs. So if in an exam we're asked to graph or plot something, it tends to mean we make a table of it out on paper or using our calculator, and then the points we put in are going to be 1x apart, as in when we'd be putting in our points, we'd start at x is -1, then 0, then 1, then 2, and so on. For sketching, what we use is something very different. We know the general shape of the function. We know what straight lines, what quadratics, what cubics, what exponentials, and so on should look like in general. And then we find a few key points on those functions, on those lines, and then we're going to use that to draw a fairly accurate sketch of the graph. Now, this can come up as a direct exam question, but more importantly, it helps us understand the shape of functions so that when we get other types of exam questions, we have an image, we have an understanding of what the function looks like and how it behaves. So this is a really critical way of being able to understand how to start lots of questions, even though sketching itself may not come up as often. So let's start off with straight lines. And I'm going to show you quickly two different ways that we can do this. The first one is if you get the equation in general form, we might then choose to just find where the line crosses the x and the y axis. And then because it's a straight line, we just draw a ruler straight through those points and our job is done. So if we start with this line here, 3x minus y minus 1, we would look for where it crosses the x-axis, and we know when something is crossing the x-axis, its y value must be 0. That's universally true. So let's just set y equal to 0. And then rearrange to get x by itself to find our coordinate. So 3x is equal to 1. We want to know what x is. So that tells me that x is equal to a third. So I know the point a third, 0 is on my line. And I need my second point, so I need to know where it crosses the y-axis. And I know that on the y-axis, x is always 0. So let's set x equal to 0. 3 on 0 minus y minus 1 is equal to 0. And we may as well just add y to both sides in this case and save ourselves changing the sign. So minus 1 is equal to y, which is the same as saying y is equal to minus 1. So that means that we have 0, minus 1. Those are our 2 points on our line. So we can go over to our graph. If we hadn't already been given it in the exam, then we would say, well, what's the biggest and the smallest x and y value that I'm interested in the question that I know about? And then I would use that to tell me how big I needed to draw my axis. And now we'll draw that in. So we're going to go to our point 0 minus 1 is on the line. And we are going to go to a third 0. And that means that we're at about 0.33. So about of the third of the way across. So we draw our 2 points in and then draw a straight line through them. So that's one way. Another way, which is in some ways more useful, although requires more thinking, is to think about our line in the form y is equal to mx plus c. So y is equal to, our y value is equal to the slope times the x value plus the y-intercept. And our slope we know means rise over run, and the y-intercept means if we had this line here, that the point 0 minus 1 was on our line. So that means we have this fixed point of 0 minus 1. We know that we're starting, we can say that we're starting at that point. We can go back this way as well, but we're starting at that point, we'll say. And we know that our slope is going to be rise over 1 is 2. Well, 2 really means 2 over 1. So our slope is 2 over 1. Every time we run across by 1, we rise by 2. So if we run across by 1, we rise by 2. And that means that that point there must also be on the line. So we have our known starting point, where we have the y-intercept, and then the slope allows us to argue where the next point must be, and the next point on would be go across by 1, rise by 2. And then we can draw a straight line in between those points. Now for quadratics, things in the form y is equal to ax squared plus bx plus c. What we're going to do is find the x and y intercept, and we need to find the maximum or minimum of our quadratic. So we know a quadratic is either a smiley face or a frowny face. And if it's a frowny face, it's going to have a maximum. It's going to have a high point that it goes to. And if it's a minimum, it's going to have a low point that it goes to. And we have two ways of finding the max or min. We can complete the square, or we can use calculus and set dy dx, the slope function, equal to 0. We must know both methods. This is not an either or. We have to know both. So if we have our quadratic example, I'll write it in. So we have our quadratic here, and let's start off by finding where we cross the y-axis. So we know that at that point, x is going to be 0. So we just set x equal to 0. You also know that if we have a polynomial written out like this, that means that the constant on the end is the y-intercept, just like it was for straight lines. So we sub that in, and we get minus 6. So we know that the point 0, minus 6 is a point on our quadratic curve. And now we can find where we cross the x-axis, and we know that y is going to be equal to 0, and we know that we call that the roots of the equation where we cross the x-axis. So we have 2x squared minus 4x minus 6 is equal to 0. We're effectively just solving this quadratic. I see I have a common factor of 2, so I'm going to divide both sides by 2, and I'm going to have x squared minus 4x, x squared minus 2x minus 3 is equal to 0. Solving my quadratic, I end up with x minus 3 on x plus 1 is equal to 0. So x minus 3 could be equal to 0. X plus 1 could be equal to 0. Rearranging. I have x is equal to 3, and I have x is equal to minus 1. And continuing, I need to know I know my value then is 3, 0, minus 1, 0. So I now have lots of points, but that I can get even more because I can also get the max and min. So we'll do completing the square to begin with. So a quick recap on completing the square. Take out any common factor in front of the x squared. No matter how awkward that makes our numbers, we must always have just x squared here. And then we are going to add and subtract half of the number in front of the x, half of the coefficient of the x. So in this case, that's equal to minus 1. So we are going to add and subtract the square, I should say, of half of the coefficient in front of the x. So we're going to add and subtract. Obviously, we can't just add it in because that would be changing the equation. But we could add and subtract minus 1 squared, and that would sum to 0. So y is equal to 2 on x squared minus 2x plus minus 1 to be squared minus minus 1 to be squared minus 3, all in brackets. We have now constructed this to be a perfect square. So that is now 2 on x minus 1 to be squared. Minus 1 squared is 1, so minus 1 minus 3, and we multiply everything out. 2 on x minus b squared minus 8. So we now have our square completed. And how does this help us give us our max or min? Well, the smallest value that can come out of our bracket is 0. So any value of x we put in here will end up meaning that this part is 0 or bigger. So there's one value of x that will make this 0, and then every other value of x will make this some positive number that gets added on to this minus 8. That means that there's a smallest value of y, because every other value of y is going to have something added on to this minus 8. So if I can find out where this is equal to 0, where x minus 1 is equal to 0, that happens as x is equal to 1. At x is equal to 1, y is equal to minus 8, and that's the smallest value I can get out of y, because any other value of x will mean that we're adding something on to this minus 8. So that means that my minimum must be at 1/8. So that's one method. The other method is calculus. So we take the derivative, just using by rule. There's no requirement to do anything with first principles or anything. We multiply by the power and subtract 1 away from the power. Minus 4. And we want to know when that is going to be equal to 0. And that's going to tell us when our slope function is equal to 0. So rearranging that equation, we add 4 to both sides. We have 4x is equal to 4. Divide both sides by 4 to find our value for x. So x is equal to 1, as we would expect, because we already did it that way. And then we need to double check whether this is a maximum or a minimum. So we need to take the second derivative. So this is dy dx. So we take d2y dx squared, take the second derivative, to just differentiate again. We have to check whether that's positive or negative at the value of x we've found. So that just ends up being equal to 4, which is a constant, which means that at d2y dx squared at x is equal to 1 is still just equal to 4. Well, that is greater than 0, so that means we have a minimum. Now, we have our several points for our function, and we're going to draw them in. So we have 3, 0. One of our roots, we have minus 1, 0. We had our y-intercept was at 0, minus 6. And we found that our minimum was at 1, that should be a minus, my apologies, that should be a minus 8. And now we need to draw in our nice curve. Do not use a ruler to draw in these points, to draw straight lines between these points. They'll take a lot of marks off of you. So what we want to do is draw a nice smooth curve through these points. So we have our curve drawn in, going through all of our key points. And just as a quick aside, to remind you of the symmetry, which is important to quadratics, we had a root at minus 1 and a root at 3. We know because the quadratic function is symmetric about its maximum or minimum, that our maximum or minimum had to be halfway between those two roots. So we would have been able to figure that out that way as well. Finally, if we're given the information in quite a different style, if we were given the roots and we were given a point on the curve, we would be able to say, well, if I know the roots, I can rearrange these roots to get the factors. So using the factor theorem, that's going to be an x and a y. Rearranging these to get my factors. Oops. I'd be able to write down my y is equal to k on x minus 3, x plus 1, and then sub in my value for x and y and find the value of k. And when you sub in your value for x and y and work it on down, you get to the